Working with electricity is dangerous. That's why the three-stage safety model is in place. After you've recognized and then evaluated any electrical hazards in your work area, you can move into the third stage, controlling the hazards. There are two main ways to achieve this: creating a safe work environment and using safe work practices. Ideally, eliminating the threat posed by each hazard you've identified is the most effective way to eliminate or minimize your risk of being electrocuted. Start by turning off and de-energizing the electric circuit before you begin working on it. Next, lock out and tag out the circuit, as well as any nearby machinery. The last thing you want is for it to start up accidentally while you are maintaining or servicing the equipment. Use easy-to-see signs that let everyone know work on the circuit is in progress. Also, make sure to lock out the switch to the circuit so the power can't be turned back on. After the lockout-tagout process is complete, the circuit is still not safe to work on. You must get a properly qualified worker to test it and give you the go-ahead. Don't try to repair or operate locked or tagged-out equipment. Only OSHA-authorized employees may do so if necessary, per the Control of Hazardous Energy regulation. Another way to control hazards is by using ground fault circuit interrupters, or GFCIs. Unlike circuit breakers and fuses, GFCIs reduce the likelihood of fatal shocks by automatically switching off the power when a small amount of earth or grounded current is detected. Once the problem is fixed, you must reset the GFCI manually. GFCIs aren't the only type of built-in protection. In fact, most electrical equipment has some type of grounding system that creates a low-resistance path to the earth, a ground connection. Proper grounding minimizes risk due to dangerous voltages, so it's an important safe work practice. That said, it's no guarantee against getting shocked. During the course of your duties, you might encounter equipment that's been modified to bypass the grounding connection. This is unsafe. Avoid it. For example, someone might be using a 3-prong to 2-prong adapter, or have removed the grounding prong from a 3-prong plug so it can be plugged into a 2-prong receptacle. Equipment with these conditions should be tagged out of service until they are repaired by a qualified person, or are destroyed and removed from the site. Remember, grounding connectors are there for your protection. Bypassing them only sets you up for injury. Likewise, avoid using equipment with damaged grounding connectors. In addition to using grounding connectors, you should also wear personal protective equipment, or PPE. In fact, OSHA requires it. Using PPE is an important safe work practice and is your last line of defense against injury. Generally speaking, your hands are the most likely to accidentally touch an electrical current. That makes insulated gloves a must. For extra protection, use insulated shoes and mats as well. Finally, make sure your PPE is rated for the voltages you're dealing with. Once your work is complete, ensure you remove all the tools and parts you've brought with you. Then replace any guards you've removed. Never forget how dangerous electricity is. After identifying and evaluating electrical hazards, do everything possible to maintain safe work practices and to control the risks you and your coworkers are facing. If you do, you have every chance of avoiding injury.